Bismillahirrahmanirrahim. How are you, students? Today we will do short answers. Chapter number 10 Thermodynamics. So, the first question is, why is Earth not in thermal equilibrium with the Sun? The answer is, the Earth is not in thermal equilibrium with the Sun because it is small and far enough away from the Sun in a cold universe. And the second reason is, sun the rate of heat transfer from the sun to the earth is insufficient to raise the earth temperature to almost 6 degrees celsius, 6000 degrees celsius. One is, they are not in thermal contact. This is the first reason. Second, heat is not sufficient. Heat is not sufficient to raise the temperature of the earth. The distances. Third is, they are the distance between earth and sun is more. So it earth will never come in thermal equilibrium with the sun. It will come in thermal equilibrium in thermal equilibrium only on doomsday, when the sun temperature increases, the size of suns increases due to nuclear fission and fusion reaction on the surface of the sun. It will take the earth in it will for example, if it is the I will erase this, then I will write, for example, it is sun, so its size increases day by day. The earth, if earth is at this distance, one day it will comes in the region in which the sun temperature increased. There will be no heat gain. Heat, it is called heat death. Nobody will gain heat, nobody will lose heat. So heat loss or heat gain will stop, and that will be doomsday. Now the next question is, when a block with a hole in it is heated, why does not the material around the hole expands into the hole and make it smaller? The answer is, when a block with a hole in it is heated, the material as well as the hole expands. Material as well as the hole also expands. The holes also expand because when the object material expands, the atom move apart and the hole increase in size. That is why the hole being expanding, the block does not become smaller. Now the next question is, thermometer is placed in direct sunlight, will it read the temperature of the air? Yes, it will read the air temperature. Or of the sun, it cannot read the sun temperature. It measure the temperature of light rays coming from the sun or of something else. It can measure the temperature of the substance from which it is made. When thermometer is placed in direct sunlight, initially it will read the temperature of its surrounding. or temperature of air surrounding the glass bulb or the sensor, which could be metal also. A normal thermometer cannot be used to measure temperature of sun as both are very far away from each other. So, a thermometer which is on earth's surface is far away from the sun. If the thermometer is kept in direct sun for a longer period of time, the temperature of its sensor will increase due to direct heat radiation from sun falling on it. Therefore, it will show a temperature higher than the true temperature. Temperature. Now, the next question is the pressure in a gas cylinder containing hydrogen will leak more quickly than if it is containing oxygen due to the size of molecule. Smaller size of hydrogen molecule, it will leak more quickly as compared to oxygen. Oxygen molecule is larger in size as compared to hydrogen molecule due to their atomic structure. Since the molar mass of hydrogen is 16 times less than the molar mass of oxygen, molar mass of hydrogen is 16 times lesser than oxygen, so it will leak because the rate of leak of a gas is inversely proportional to the square root of its density, so it will leak more quickly. Hydrogen is small, very small. It can perfuse through the passage and even slip into the spaces between large molecules. Oxygen molecules are much larger. Helium does the same. When helium oxygen saturation, you can read this. The simple answer is the molecular size is smaller as compared to the oxygen molecule. The molecule size of oxygen, hydrogen is small as compared to the molecule of hydrogen. Now, the next question is when a sealed thermoflask bottle full of hard copy is shaken, what are the changes, if any, in temperature of the copy, the internal energy of the copy? What will be the change in the internal energy if you shake the thermos flask? What will be the change in temperature of the copy and internal energy? When a sealed thermoflask bottle full of hard copy is shaken, then work is done. When work is done, the system thereby increasing the internal energy. So internal energy increases. And the rapid shaking causes increase in kinetic energy of the molecule. That is why both temperature and internal energy increases. Rapid shaking increase the kinetic energy, so both will increase. Now, the next question is when an object is heated, it is given in numerical 7. Object is heated. Not all the energy it absorbs goes into increasing the velocity of the molecule. Explain, where does the remaining energy go? Listen the question again. When an object is heated, it will not absorb all the energy. The energy absorbed goes to increase the velocity. Explain, where does the remaining energy go? The answer is when an object is heated, some of the energy goes to increase the velocity of the molecule. Some energy is utilized to overcome the intermolecular attractive forces. Remaining energy may be utilized in phase transition. So, the energy absorbed is increased. A portion is used to increase velocity. Some of its portion is used to overcome the intermolecular forces. Intermolecular forces. And the third, phase transition. Phase transition. Now, next question is, why does the pressure of air in automobile tire increase of the automobile is driven for a while? When you go online drive, pressure increases. When you drive a car, why? Pressure increases when you drive a car. So when you drive a car, pressure increases because when an automobile is moving on the road, some work must be done to overcome road friction. Road friction, due to which the temperature of the tire increases. The work done causes the temperature of the air in tire causes increase in temperature of the tire. The temperature rises the average kinetic energy of the air. Since the kinetic molecular theory, kinetic energy is directly proportional to pressure. Kinetic energy is directly proportional to pressure. Is directly proportional to the pressure of the air in automobile tires. So it increases the pressure. So when you drive a car, the pressure inside the tire increases. It is due to the friction between the road and tire increase the temperature of the air inside the tire, which causes increase in pressure. Now the next question is question number 9. On removing the valve, the air escaping from a cycle tube cool. Why? The air is the air inside the tire. On removing the air opener, the air escape from a cycle tube expands rapidly in a nearly the air inside the tire is compressed. Air is compressed. So when it escapes from the tire, it expands. When it expands, the process is adiabatic. So when the process is adiabatic, so the temperature of the gas drops. That is why the air escaping from a cycle tube feels cool. This is sometimes called adiabatic cooling. The molecules of a compressed gas in a tube are very close to each other and have sufficient intermolecular attractive forces. When the gas is allowed to expand, the molecules move further from each other. Due to expansion, the molecules have to overcome the intermolecular forces. For this purpose, they need energy which is absorbed from the gas itself. Hence, expansion of a compressed air escaping from a cycle tube causes cooling. Now, the 10th short answers is: can a room be cooled leaving the door of electric refrigerator open? No. If you keep the door of refrigerator open, will it can cool the room? No. The answer is no, because LTR is room. Room is LTR, and HTR will be also the room. So practically it is not possible. What are the conditions for the process to be reversible? Condition for the reversible process: a process must be reversible process in which the succession of events bring the system back to its initial condition is called reversible process. Although no actual change exactly reversible, but if the following conditions are satisfied, then the process will be reversible. Thermal and mechanical equilibrium must be maintained throughout the process. First, thermal and mechanical equilibrium will be maintained throughout the process such that dissipation of energy may not occur. The second condition is the process must be occur very slowly such that at an instant of time the temperature of the system remains constant. Process must be slowly, that state variable remains constant. Write the limitation of first law of thermodynamics. So limitation of first law of thermodynamics is first limitation is this law is based on the idea that energy is neither created nor destroyed in any thermodynamic system. So it is a particular form of law of conservation of energy which deals only with the heat energy. Law of conservation of energy must be obeyed. Conservation of energy. If it is violated, this law will be no more applicable. First law of thermodynamics tells us that heat energy can be converted into equal amount of work, but it is silent about the condition under which this conversion take place. The heat can be completely converted into work. Practically, it is not possible. So theoretically, it is correct. Now, next numerical short answers. When the system in thermal equilibrium, when the system are in short answers number 14. When the system are in thermal equilibrium, do they have the same amount of kinetic energy? Two systems are said to be in thermal equilibrium if both have the same temperature. Since temperature is a measure of the motion of molecules, temperature is direct proportional to average kinetic energy. So when two systems are in thermal equilibrium, both have the same temperature, same kinetic energy. Work can be converted completely into heat. So can heat be converted completely into work? Work can be completely into heat. Work can be converted completely into heat. So can heat be converted completely into work? We have to explain this statement. Work can be converted completely into heat, but heat cannot be converted completely into work. Otherwise, it will violate the second law of thermodynamics, which is no heat engine continuously operate in a cyclic process. No heat engine can operate completely in a cyclic process. Entropy is often called as time arrow. Explain. Since entropy of the universe always increases. When any type of energy is converted into heat energy, the energy available for doing useful work decreases. When energy is continuously degrading for doing useful work, ultimately the entropy of the universe reach a maximum, which is called heat death of the universe. All process will cease due to unavailability of useful energy. That is why entropy is called as time arrow. Question number 17. Can specific heat of a gas be zero or infinity? Can specific heat be negative? We know that Q is equal to Cm del T and C is equal to Q divided by M del T. which shows that for a zero specific heat, the heat supplied to the system Q must be zero, or mass M must be infinite, which is not possible. Similarly, for negative specific heat, if Q is given out of the system, this specific heat can be negative. Now, the last one. I will write the data, do it by yourself. An, in, uh, an inventor claims he have developed a heat engine working between 27 and 2 T1 is T1 is 27 degrees Celsius, 300 Kelvin. T2 is equal to 227 degrees Celsius is equal to 600 Kelvin. Sorry, 500. 273, 227. It's 600. 227, 273. 10, 7, 8, 9, 9, 10, 4, 5. It's 500. 500 Kelvin. Now, calculate the efficiency. Efficiency is equal to 1 minus T2 divided by T1 multiplied by 100%. This is percentage efficiency. Having an efficiency 45%, is the claim is valid? Explain. You will solve it and answer the question. It's you will get 40% answer. The claim is not valid. Thank you, students. Your inshallah we will start the revision in next lecture. Wish you best of luck. Allah Hafiz.